This video is going over Priority Standard 5.6, which is talking about constant speed. Make sure you fill in your learning target for today. I can use mathematical strategies to help create equivalent ratios, so equivalent ratios related to constant speed. So that's what we're working on today. So finish your warm-up if you didn't finish it in class or if you weren't here. I'm going to move on to our first activity. So moving for 10 seconds. So 10 seconds is just under 10 seconds is the world record for the 100-meter dash. So some people can move very far in 10 seconds. However, most of us can't move as far, right? So we have Lynn and Diego here in our problem. Lynn and Diego ran for 10 seconds, each at their own constant speed. Lynn ran 40 meters and Diego ran 55 meters. Who was moving faster? So first of all, if we know Lynn ran 40 meters and Diego ran further in the same amount of time, we know the person who ran further in the same amount of time is going to be faster. So I would say Diego ran more meters in 10 seconds, right? So that means he's faster. If you have a different way to explain it, that's just great. Then it says, how far did each person move in 1 second? So this will be kind of like the speed. So I'm going to look at Lynn. I know Lynn's ratio to meters per second is, or in seconds. So if we have 40 meters in 10 seconds. So in 1 second, we're going to divide 10 by 10 to get to 1 second. So I'm going to divide 40 by 10. And I know 40 divided by 10 would be 4. So Lynn runs 4 meters, and I'm going to call it per second. Okay, then I'm going to look at Diego. So Diego is our next guy, and Diego, meters per second, we know is 55 meters in 10 seconds. So in 1 second, 10 divided by 10 is 1. So we're going to divide 55 by 10. 55 by 10, we just move the decimal to the left one time, and it would just be 5.5. So he goes so Diego runs 5.5 meters per second. Lastly, Han runs 100 meters in 20 seconds at a constant speed. Is this speed faster, slower, or the same as Lynn's and Diego's? So there's a couple ways to do it. We can find out how far Diego ran per second to find his speed, Han ran per second to find his speed, or we could compare it to 20 seconds. So I'm going to look at Han. I'm going to create a table for Han. If we're talking about meters and seconds, his is 100 meters in 20 seconds. So I'm going to look at how far he runs in 10 seconds because I already know how far the other guys go in 10 seconds. So I know 20 divided by 2 would give me 10. So I'm going to divide 100 by 2 because that's easy for us. Half of 100 is 50. So he's going 50 meters in 10 seconds. And I'll just take it one step further to see in 1 second. 10 divided by 10 is 1, and then 50 divided by 10 is 5. So Han runs 5 meters per second. So we know if he goes 5 meters in a second, he's running faster than Lynn, but slower than Diego because Diego goes more. So the fastest is Diego. Then Han and Lynn is the slowest. Okay? So find out what his speed is and then make sure you show your work so we can support our answer there. Moving on to activity 2. So we got concert tickets and we got some sparkling orange juice, and we're going to answer some questions about these things. So the same rate. We use the word same rate to describe two situations that have equivalent ratios. So we know people are running, for example, at the same rate if they're running at the same speed. because they have an equivalent ratio. We know things taste the same if they have the same rate, and so on. So let's look at these problems. Diego paid $47 for 3 tickets. Andre paid $141 for 9 tickets. Did they pay at the same rate? So there's a couple ways to show it, and you can show it any way you want, and then check to see if you got the same answer as me. So Diego, it is $47 for 3 tickets. Andre's is $141 for 9. So I know 3 times 3 would give me 9. So let's see if 47 times 3 gives us 141. And if so, then that means these are equivalent ratios, so they paid at the same rate. So I'm going to do 47 times 3. 3 times 7 is 21. 3 times 4 is 12. 12 plus 2 is 14. So 141. So 47 times 3 is 141. So yes, they paid at the same rate. Same rate, and my work shows it because they are equivalent ratios, or they have equivalent ratios. You could also see how much both of them paid for 1 ticket and then compare to see if they both paid the same amount for 1 ticket, but it just takes a little bit more time. But all the ways work as long as you prove that it's the same rate. Number 2, Lynn and Noah each have their own recipe for making sparkling orange juice. Lynn mixes 3 liters of orange juice with 4 liters of soda water. Noah mixes 4 liters of orange juice and 5 liters of soda water. How do the 2 mixtures compare in taste tests? Okay, so this one's a little weird. So we have Lynn. Let's come up with a ratio. We have orange juice, so I'm going to say OJ, and SW for soda water. So her ratio is 3 to 4. So I'm going to see how much, I'm going to come up with a batch where either both of them have the same amount of orange juice or both of them have the same amount of soda water. So I'm going to draw another one for Noah. And again, there's a lot of ways to do this. So if you did it a different way, great, as long as you can prove the same thing. So Noah's ratio is 4 orange juice to 5 soda water. So I'm going to think, okay, what's something I could multiply both of the orange juices by to get the same number? So I'm going to multiply 3 by 4 to get 12. And then I'll multiply this one 4 by 3 to get 12. So we can compare it when they both have the same amount of orange juice. So if I multiply Lynn's by 4, then I have to multiply the other part of her ratio by 4. So 4 times 4 is 16. That would give me an equivalent ratio. So when she has 12 orange juice, she uses 16 liters of soda water. So Noah, since I multiplied this by 3, I have to multiply the 5 by 3. 5 times 3 would give me 15. I notice they both have 12, but they both don't have the same amount of soda water. So what I have to think is, okay, if they both have the same amount of orange juice, Lynn's has more soda water. Hers has more soda water, so hers is going to taste a little bit less orange juicy. And Noah's is going to taste a little more like orange juice because he has less soda water. Okay, so let's see how it says. So it says Lynn's mixture tastes more blank than Noah's. So there's lots of ways you could do it, but I could say Lynn's mixture tastes more, I'll say soda watery, because she has more soda watery, if that's a way to describe. Noah's mixture tastes more, and I'm going to say orange juicy, because he has a little bit less soda water. So I'm going to say orange juicy. But you got to explain. You could say Lynn's uses more soda water with the same amount of OJ. Okay? So when we try to compare things like this, we want to check to find one part of the ratio that is the same, and then we can compare the other part to know if they are equivalent or if they are different. Great. Thank you for watching the video. Now you are doing the cool down. You got some trains on different tracks and you're going to be comparing.